Happy May Day. Our goal today is to simplify rational expressions. And just a reminder that expressions don't have equal signs. So we're not solving equations, but just simplifying the expression. That a rational expression is a lot like a rational equation, that it's in the form of a polynomial divided by a polynomial. And that when we're simplifying, what we mean by that is that it's fully reduced and that there's no common factors. So when we simplify, we factor and then we divide. So a couple straight up examples of that. When we simplify 2 over 6, we look for, like, this is obviously, you would say in your head it's 1/3, but really what you're doing is you're noticing that 2's factors are 1 and 2 and 6's factors are 3 and 2. So once you factor it, you can reduce by that factor of 2. You multiply both, divide the top and the bottom by 2. So you end up with a 1 over 3. So I started with like a basic straight up example of, obviously you've been doing this for years, right? So then we start to work some variables into it. We still think about the factors that make up the number. So on this one it's 2 times 6 and then 2. We can cancel. At that point we can cancel the 2's and we're left with 6 over x squared. And then just maybe to point out the obvious, but sometimes when we start working with variables we kind of forget the basics. If I had something like 2 plus 1 over 2 plus 5, sometimes again, if I had a lot of variables in here, I would see students canceling the 2's. But we can only cancel factors. We can't cancel terms. So you know, obviously, when I'm just looking at numbers that I can't cancel those 2's, that this would just be 3 over 7. So the same thing is true when we have variables worked into it, that I can't cancel these n's. Because n is not a factor here, it is a term, so I can only cancel factors. So there's nothing more I can do with this one. On this one, I have factors, so I can't cancel until, excuse me, I just said that last part wrong. I have terms, so I can't cancel. So I have to make factors. So in the denominator, I can factor out a 6 out of both terms, and I can factor out a y out of both terms. So I've got 6y, and then I've got left y minus 7. And I just always do a quick mental check. I go back the other direction to make sure I didn't make any mistakes. So 6y squared, check, minus 42y, check. Okay. So then I've got 3y squared in my numerator. So now I can cancel the 3 and the 6. So I've got 1 over 2. I can get rid of one of these y's and this y. So on the top I'm left with 1y, which I'm going to just make that y. And then on the bottom I have 2 times y minus 7. And I could simplify that to 2y minus 14. On this one, we get a little fancier. This, we're just factoring out the greatest common factor. Here, we want to look at, can I factor this? And so we're going back to a couple units ago where we factored a lot, and we should recognize that this is the difference of 2 squares. So when I factor that, it's going to be 1 minus 7, 1 minus z, and 1 plus z. And then I've got z minus 1 in my denominator. And I want to try to cancel things if I can. So like right now, this is a term and it doesn't match either of these terms, but I could factor a negative out of this. So I could make this, I'm going to actually come over here, I could make this negative z minus 1. So that gives me the negative times the negative gives me the positive 1, negative z. So again, I'm factoring out that negative. And then I've got 1 plus z all over z minus 1. So now I can cancel that factor and cancel that factor. And I'm left with negative 1 plus z, which is going to just be negative 1 minus z all over nothing. So that's my simplified expression. I want to come back up here and go through these examples again with another question. So one of the things that you're often asked to do when you're simplifying rational expressions is also identify the excluded value. So we know from the work that we were doing with graphing that we can never have a 0 in the denominator. So a lot of times when we're doing this simplification, we also have to answer the question about the excluded values. Obviously, in this one, we don't have an excluded value because we don't have a variable. On this one, my excluded value is going to be 0. So I would either just say that 0 is an excluded value, or I could say that x can't equal 0, or I could state that the excluded values are x equals 0. On this one, it doesn't matter if I go back to the original equation, because x can't be 0 here, or the simplified expression where x can't equal 0 there. But in general, we actually do go back to the original equation to determine our excluded values. So we'll see in a minute where that makes a difference. On this one, I was just giving you examples of numbers, so we don't have an excluded value there. On this one, n can't be negative 8. So we would say that n can't be negative 8, or excluded value is n equals 8. Excuse me, negative 8. And so it gets said both ways. The book actually usually writes this whole sentence out. The excluded value is n equals negative 8. I usually write n can't equal negative 8 because it's easier. But you'll see that both ways. On this next one, we're going to look for the excluded value. And if you look just at the simplified form, you would say that the excluded value is 7. And that's true, but 0 is also an excluded value. So when we're looking for the excluded values, we want to go all the way back to the beginning. And here, it'd be hard for me to tell. So then I'm going to go to the next step, and here all I've done is factor it. And before I start reducing, before I start crossing things off, that's when I look for the excluded values. So I know that this term can't be 0, so y can't be 0, and this term can't be 0, so y can't equal 7. So y can't equal 0, or y can't equal 7. So notice that if I just looked at my final simplified expression, I would have only identified the y equals 7 as the excluded value, but I've got to go back to before I start crossing things out and canceling to find that other excluded value. On this one, I go back to my original, and I have z minus 1, so my excluded value there is z cannot equal 1. At this point, that's the end of the lesson. You have some practice on Clever. I am going to do some more problems for those of you who said, wait, I need to check my work before I move on to Clever. So I've got some more practice problems here that I'm going to let you pause the video and do, only if you want to. If you're saying, I got it, I'm ready to go on to Clever, you're welcome to do that. But here's a couple more that you can do on your own. Pause the video, and then when you unpause it and come back, I will have the answers on here for you to check your work. All right, so now that you've had a chance to work on those problems, I'll go over the answers for you. The first one I actually wrote down incorrectly, so I had already paused the video, and I knew that you had as well, so I didn't change it. So this problem, as I wrote it down, there was no simplifying possible. If I had written it down correctly, it would have been 28 here instead, and I would have been able to factor out a 7. So then I would have factored out a 2 on the top and a 7 on the bottom. Those polynomials would have been able to cancel each other, and I would have ended up with 2 over 7. When I'm looking for the excluded value, I'm going to go back to the beginning to notice that b cannot equal negative 4. because that would make negative 28 plus 28 is 0, and that's not possible. So even though at the end I end up with an expression 2 over 7, and you would think that there is no excluded value, you have to go back to the very beginning. On the next one, I'm going to factor out a 2 and then a 4a. When I do that, I can cancel my a minus 3 factor, and then I can reduce 2 over 4, and I'm left with just 1 over 2a. Again, when I'm looking for excluded values, I'm going to go back to the factored form before I start canceling. So I know that 4a can't equal 0, therefore a can't equal 0. And a minus 3 can't equal 0, therefore a can't equal 3. This final problem, I'm going to factor this into z minus 8, z plus 2. And I notice that my denominator has the same terms with that, they're in the opposite order, so I'm going to factor out the negative there, and then I end up with z minus 8. So I'm trying to create factors. Like, I wouldn't always have to factor that negative out, but if I have something that I could cancel it with as a result, I want to do that. So again, only to give me something to reduce, but those two will go away, and then I have minus, and that doesn't matter if it's in the denominator or the numerator, so it's minus z plus 2. That minus gets distributed, so I get minus z minus 2. Again, to look for the excluded value, if I just looked here, I would say I have no excluded value because I have no denominator. But I need to go back to the beginning or the fully factored form before I started reducing. And I know that z cannot equal 8 because that would end up with a denominator of 0. So now you get to practice on your own. You have a clever assignment. Good luck. See you Monday.